Okay, this is like the third time I'm trying to record this, so I hope this time it works. Okay, so this is meant to help you with homework 1, and I'm just going to breeze through a couple of the main problem types in problem 1, and just show you if you're in 1.1 and you're working on problem number 5. This is the skills you need. I'm not going to actually do problem 5, I'm just going to give you hints. So if you have coordinates, say the first coordinate tells you how far to the right to go and the second coordinate tells you how far up to go. So for example, over 3 up 7, this would be the point 3, 7. But if one of these guys is negative, instead of going, say, right, you go left, or instead of going up, you go down. So for example, if it's -1, -1, you'd be down here. You'd be to the left 1 and then down 1. If you happen to be glued to an axis, like this would be the point 0, 7, because you're not going right or left, you're just going up. But you can just label the axis with a 7. So if I put just like a 1 here, it just means 1, 0. Okay. I guess that's all. You guys didn't seem to have trouble with that in class. I'm not going to belabor that. Every time I start doing a different problem type, I'm going to just put the new problem numbers up here so that you know, and you can just scroll through this video. You don't have to watch the whole thing. So 17, problem number 17 through 21, those problems are all the same type. Those ones are distance between 2 points. So as an example, this problem. Okay, what we just do for you formula people, you can just do this. Distance is going to be change in, I guess people usually put the x's first, it doesn't matter. And for this formula you can switch the x1 and the x2, that doesn't matter either. As long as you keep the y's together and put the x's together. So you just shove it into that formula. Change in x's is going to be 15 squared, change in y's is 8 squared. And if you work this out, it's 17. So the way you do this on a calculator, you would say 15 times 15, and then you probably know 8 times 8 is 64. And then what you can do to take the square root, you can say to the power of 0.5 so that you don't have to retype that 289, and that will give you the 17. Okay, so that's how you deal with that type of question. I would say note, M is change in y over change in x, so you don't want to confuse these formulas. In both the distance formula and the slope formula, you want to take the difference of x's and the difference of y's. But the follow-through is different in those two kinds of problems. Okay, next problem type is 23 through 24, and in this case you're given some kind of a right triangle, and you're going to have some coordinates listed somewhere on there. So maybe you have something like this. I'm trying to make this up. Hopefully that works. So anyway, the question could be posed, tell whether this satisfies the Pythagorean theorem or not, in which case you say, wait a minute, this is a distance of 4, and this is the distance of 4, and, well, you're not going to get an exact integer. Actually, aha, I understand what it's saying. So the question says, find the length of each of the triangle and then show that the lengths satisfy the Pythagorean theorem. Okay, so we're good. All right, so now what we want to do is we want to find the distance here. So the distance 7 minus 3, what is 7 minus 3? This 7 minus this 3 is 4, and then this 7 minus this 3 is 4, and so you're going to get square root of 32, which I'm just going to leave that way for the moment. Now I want to verify that these distances satisfy the Pythagorean theorem, and so I'm just going to say, well, it just does. It's actually pretty easy because this one never got unbound. Like it's right here, right? We use the Pythagorean theorem to find the distance between these 2 points. So anyway, that's just a simple little question. Let me just do another one. I just make up any old type of question. Let's see. Let's take any old points and see if it works. Okay, my computer's not being cooperative right now. Okay, so I'm going to just say 4, 7, and then if the over number is changing, but the up number is the same, then I'll get something like that. Now the over number has to be the same, and the up number has to change. I don't want to be that pathetic again. Okay, there we go. That's a little better. So then this distance is going to be 13, and then this distance is going to be 10, right? And so the distance between these 2 points is going to be, okay, y change squared plus x change squared under the square root. Now, who knows what that is? I don't know. 13 squared is 169, so we get 269 is the distance. And we want to show that the distance is equal to 13 squared plus 10 squared under the radical. But like I said, we just did that. So the question is a little bit silly. Granted, I didn't write the question. But the whole point of the question is to just get you using the Pythagorean theorem and being comfortable with it. Okay. Now what next? 36. Data analysis, exam scores. The table shows blah, 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 sketch the points. Okay. So when you have a question that says sketch the scatter plot, you're just doing the same thing as we did in question 5. It's the same. So question 46 is equal to question 5. It's just that it's in a grid. You just have the x's and the y's, so like 22, 53, 29, 74, etc. And so what you do is you just know the the lowest number here is like 22, and the highest number is, I think, 76. Down here, the lowest number is, I don't know, 57, and the highest number is 99. So you just keep that in mind and you say, okay, so I'm going to make my grid from, say, 20 to 80 on the x's, and maybe I'm going to go from 60 to 100 on the y's, and then I'm just going to estimate. So 22, 53, okay, so I was wrong. If the smallest number is not 57, what is the smallest number down here? It must be 53. So let's make this number down here 50. Alright, so 22, 53 is about here. You don't have to label them, but I'm just labeling them because I'm making such a mess. And then 29, 47 might be, like, you know, 29, 47 is 29, 74. That's why I'm having trouble. 29, 74 might be roughly here. And you could also use Wolfram alpha to generate these points. I'm going to set that up for a second. Okay, you can see how much time I wasted. I was unable to figure out how to get Wolfram alpha to plot points. It only plots lines. So if you give it a list of points, it'll connect the dots. It's really obnoxious. So if you want to see where the points are, go ahead and ask Wolfram alpha, but it's just going to make a mess of your page. Okay, so next question is, actually I'm going to stop this video and make separate videos for each section.